How to find derivatives using product and quotient rules. Coming up, back into action. Hey guys, how to take a derivative if you are given two functions being multiplied together. So you are given a product of two expressions, of two functions being multiplied together. Well, the first way that comes to my mind is just straightforward. All you can do is just open up the parentheses, remove them by multiplying things out, foiling things out, and you would come up with a polynomial in terms of x, and after you will be able to apply a power rule at that point. By the way, I have a video where I explained and I showed some examples on how to do this way. You can check it out later. Now, there is shortcut, a surefire way, I would say, that's basically called a product rule. What is a product rule? Product rule basically claims that if you are given two factors, let's call them u and v, being multiplied together, that the derivative of the product equals the derivative of the first function u prime times the second function as is v, untouched, plus added the first function u as is times the derivative of the second function v prime. This is the product rule, alright? Now, the second line, I've just wrote this product rule just by using another notation. This is dy dx notation, but this one precisely the same, absolutely the same thing as this one. It's the same product rule. Alright, let's take a look how does it work. Suppose you are given these two functions, namely 3x plus 4 and 2x squared minus 1. So as I mentioned before, if you feel this way, you can simply use algebra first, multiply and distribute out, remove the parentheses, and after take the derivative. It's totally fine, it's totally valid. Go ahead. But let's try a product rule. So your u term is this first entire parenthesis. So you could define your u as 3x plus 4, and uv is your second parenthesis, namely 2x squared minus 1. Now, y prime equals, product rule asserts the derivative of the first one, so 3x plus 4 prime times the second function as is, 2x squared minus 1, plus the first function u as is, I'm going to rewrite it as is, 3x plus 4, times the derivative of the second function. The second function is 2x squared minus 1. Write it down. 2x squared minus 1. Alright, this is your setup. This is what we got from just applying power rule at that point. Now all you need to do, just take the derivative, multiply things out, combine like terms. In a nutshell, just use some algebra. So keep going. So the derivative of 3x plus 4 is just 3. Since the derivative of 4 is 0, it's a constant. The derivative of x is just 1. X goes away, and you will be left with 3 for the first term. Second term, I rewrite as is, 2x squared minus 1. Plus, you keep addition. Let's handle the second term. 3x plus 4 rewrite as is, and the derivative of 2x squared minus 1 is just 4x. So same thing goes for here. You simply apply power rule. The derivative of -1 is just 0. The derivative of 2x squared, since to a constant multiple rule to be precise, and the derivative of 2x squared, you would be left with 4x. So this one gets multiplied by 4x. Keep simplifying. So for the first term, you do some algebra. So just open up the parentheses. It becomes 6x squared minus 3. And here, you multiply by this entire 4x to both terms. So 12x squared plus 16x. And you have like terms. You have this squared. They have to come together. So becomes 18x squared plus 16x, and you have this -3 at the end. So this is your function, trinomial or quadratic, if you will, for that one. Again, guys, you can check out your answer by multiplying things out, falling things out after you combine like terms, and by taking the derivative, you would end up with precisely the same expression. Moving on. How about this one? Alright, things getting more interesting, more exciting. Yeah, we need some more fun. So let's get into swing. Alright, you have e, you have sine, cosine, so it's like concoction, it's like combination of exponent, exponential and trig. Alright, let's figure out this one. There is only one way, to be perfectly frank with you, of taking the derivative of this product. You cannot use algebra first. You cannot open. There is nothing to be open. There is no parentheses. There is no brackets. There is e to the -x, and there is cosine x. So basically, it pops out at you. You have first term. So you can call it u, and you have second term, you can call it v. So they're like asking you, they're begging. So they have two terms, and you have to use a product rule. Go ahead. Y prime, or dy dx, becomes, so the derivative of u, product rule, simply says take the derivative of u. U is e to the -x. Okay, this exponent function pops out. Well, recall that the derivative of e to the u is the same function, is e to the u. So this is the most beautiful function, because it's very, very easy to remember that both derivative and integral of e to the any power, e to the u, let's say, it's the same function. It remains the same. That's good. That's good. Now, so the derivative of u is the same function. So you would write e to the -x. But we are not done yet. And if you look at this function carefully, you would notice that it's actually a composite function. It's a composition of two functions. You have e and you have this power, which is basically not just x, it's negative x. And that negative would plays a huge role. Why? Because since it's a composite function and you have to use the chain rule, your term, this one, gets multiplied by the derivative of negative x, which is -1. So overall, your term becomes negative. This is very important, and if you didn't notice that or didn't recognize that this is a composite function, you would just lose this negative, but your entire answer would go wrong, would go astray. That's why, like, very little slight slip-ups, and they would cost you a lot. All right, so again, chain rule. If you are not that confident of using chain rule, I have a special video on chain rule. You can check it out also. So this is what we would get from the derivative of u. So these terms were still not done. These terms gets, and we clean up a little bit later, don't worry. And this term gets multiplied by v as is. So I'm going to rewrite cosine x. Now, moving on to the second term in this product rule. We add the first term as is, e to the negative x, and these three functions comes out as well. This is kind of a mnemonic device, a mnemonic trick to remember the derivative. So the derivative of sine is cosine. The derivative of cosine, it's not sine, it's negative sine. So it's kind of cyclical. That's why I try to do my best of drawing something. So this looks like pretty beautiful. Now, so the derivative of cosine is negative sine anyway. So we would write times then negative sine x. We're done with a product rule. Now, just simplify it down at this stage. As I said before, this negative just drag down out front. And this negative as well, we could pull it out in front, so it becomes negative overall. Well, technically that's correct, and we could stop over here, but to me, I don't feel that comfortable, to leave the answer this way. I wouldn't be sleeping next night, or maybe 2 nights. Well, this term, actually that term like pops out in you, and it actually wants to be pulled out as well. So I would just drag it outside of parentheses and take this negative as well. So just factor out this term, and you would end up with just alright, this is your final answer for that problem. Moving on. Okay guys, my special offer, my special meal, hot meal, always at the end. I'm pretty sure you're super pumped about this. Alright. Let's say you are given something ln of x over x. It's a good candidate for a quotient rule, of course. You have a quotient, you have natural logarithm on top, you have x on bottom, so you have your u and you have your v. So apply a quotient rule at that point. Go ahead. So draw a bar which represents a fraction. So let's form a top of your fraction. The derivative of ln of x. So think back to table of derivatives, and the derivative of natural log is just 1 over x from that table. So your u prime becomes 1 over x, which gets multiplied by v as is. So your v is x times x minus, keep subtracting, u as is, so we write natural log of x, and this term gets multiplied by the derivative of x, which is basically just 1. Now your bottom function becomes just x squared. Alright, this is your setup. We apply a quotient rule at this point. Now just let's clean it up a little bit. So x and this x goes away, so it becomes just 1 instead of first term. So I would rewrite my bottom as this, so it becomes just 1 minus, from the second term we would get just natural log of x, and this is your final derivative, your final answer for that problem. Guys, it was so much fun. I hope it helps you and train your brain. Thank you for watching. I know everyone hates maths, but if you like my video, just hit this like button, share with your friends, leave your comment down below, and smash that subscribe button so you will not miss my new videos.